Hi and welcome to Swap Pop Gaming. I'm Sonny. I stream on Twitch and YouTube 5 days a week, European afternoon time. And so if you have any questions, just subscribe and come in when I'm streaming or ask your questions in the comment section. My project is a gas system RPG, and I was thinking about doing a quick video about the gameplay effect execution calculation system. It's kind of hard to wrap your brain about how it's actually working, so I thought, let's put a video together and we'll explore it together. All right, we're going to look at how I set up my system here, and just to give you a brief overview on how to use it and what to expect from it. So what we're first going to do is look at what the end result we want is going to be. To start out with, we'll just press play here and we're going to see what happens. So what I'm basically going to do is, if I move out to fitting, you have the power grid and data transfer. Whenever I drag in an energy battery, what it's going to do is it's going to update my power grid to 7.5 and my data transfer to 2.5. That's basically what we wanted to do. That's the first thing. So if I drag in 2 batteries, we're going to have 15 and 5. Okay, simple. And if I move it, it's going to lower it, just like any gameplay effect does. However, let's say that we drag in a larger battery. The larger battery has a higher amount of power grid usage and data transfer. Now, if it's too big, we don't want this to activate. We want it to basically, we drag it in and nothing happens. Now, I haven't gotten to that part where I actually want something to be visual on the screen, like popping up a text, like overload a power grid, and therefore it's going to be not active. Basically what we want to say here is that we don't want the gameplay effect to kick in if we break some rules. And to do that, we cannot use the regular gas system gameplay effect. We need an effect execution calculation to do that for us. If I look at my load slot testing gameplay effect here, this is the regular way of doing it. So I have an infinite system. So whenever I add it, it will add it. And whenever I remove it, it will remove it from the system. Now, my mid slot, which is a battery, is going to use something called an executive calculation instead. And it's below everything else. So if you look at my modifiers is actually empty and my execution is filled out. So I fill in the class of the execution, then I'm filling in the information down here, what I want to do, if I want to add it or values I want to add at levels, etc, etc. The key here is that it cannot be used with an infinite duration. It has to be instant or has duration. So how do you fill this out? Well, you need an execution class. An execution class is basically a class of type UGameplayEffectExecutionCalculation. I called mine execCalc_fitting because this will only handle fitting and unfitting of modules into my system. So you need 2 things in here. So you're creating this C++ file, and then you add it to your gameplay effect here, calculation class. Now you have attached it. You're going to have some backing data. We'll look at that in a second. But otherwise, we're just going to add the regular stuff like add, scalable float, and you add your curve table, for example, and choose the scalable float that you want to correspond with your attribute. What we're going to do is we're going to take a look at the file, how this actually works. So you need 2 things here. You need a constructor and you need this function, virtual void execute implementation. You need to look exactly like this. You need to have the gameplay effect custom execution parameters. It need to be called execution params. You need to have the gameplay effect custom execution output. So this is the output that is going to be sent on to the rest of the gas system whenever you're finished. It's going to be a const and it's going to be an override. So this is the only thing you need. So it looks pretty simple to start out with. Let's go into our actual CPP file. The first thing we want to do is we want to make sure that we know what attributes we are targeting, right? So we need to define the attributes that we want to capture. The 3 attributes I want to capture and update: the power grid and data transfer. Those are the values you saw on screen that went up whenever I added something. And then I got max energy, and max energy is what the whole battery thing is about. That is it will increase the max amount of energy you can use with this vehicle. So what we're doing is we are forming a struct here. I'm calling it GD ship fitting statics, and I'm declaring the attribute capture definition. So I'm going to have the power grid, the data transfer, and the max energy. Then we're going to create a constructor for this struct, and we're going to define attributes capture definition. And here we got my attribute set. You're going to use your own attribute set, and here's the attributes that we are getting. So it's the power grid, data transfer, and max energy. Next, we want to see, is it the source or the target? So what's the difference? Well, the source is who sends out this function, who is calling it. And the target is who is it targeting. Now, when we're adding it, we want to add it to something. We want to add the information to our vehicle, right? So we take the target and apply it. But you could grab the information from the source as well. For example, if you have a damage application, for example, you want to know if how big is the chance that the target get hit, depending on certain values that you might have on the source or the target. The next third part here is a snapshot. A snapshot is basically saying when you want to grab the information, at what point in the process do you need that information. This static const is basically just a helper function that will help us make sure that we're calling the same static over and over again, so it doesn't recreate it every time. It's actually storing it and returning it over and over again for us. So the next thing we want to do is we want to capture the attributes, and that's what we do here. And we're using this helper function, the ship fitting statics. We're grabbing the definition of the power grid, data transfer, and the max energy. So we're putting that into our constructor, so we are now able to use that information from the system. All right, so here we go. Here's the execute implementation. That's the function we created when we created the file, right? So what are we doing here really? Well, we're grabbing, for example, the gameplay tags. If we have any gameplay tags attached, I do, because I want to know if we're adding it or if we're removing it. If we remove it, is it even active? I need to have that information. Whatever your information need to be, that's up to you. So the next thing we do is we are grabbing the target avatar here. Reason I do that, because I want to be able to get the target avatar, so my vehicle, and I want to check a component on it. For this time, it's going to be the slot manager, and I want to call functions on that depending on, for example, have too much power grid, for example. Then I want to inform the user about that, set the image of the slot into a darker image, and certain things like that. So I want to be able to access the target. Then we're going to create a spec. And then we are using that spec. That's the information coming out of this execution parameter. So all the information that you have a lot of information to play around with when it comes to the gas system. Anyway, from this system, I'm going to grab something called get context and get source objects. So now I have access to the actual module. So now we have the module that I'm dragging in, because that's its own item, right? It's its own little class. And I need to be able to set certain aspects. For example, if we activate it, we need to set an activation tag on it, or at least an activation bool in my case. Or if it's not active, we need to be able to set an inactivating thing on it, so we can do things with it. So we can check, is it activated when we are removing it, or if it's not activated. And then we're going to get the effect context handle. We're doing that here. There's also something we will be able to use further down in the code. So these are basically things that you always want to grab all these things is something you have in every file. You just want to grab it because there's a ton of information from all this that you will be able to get. Here we are grabbing the tags from the spec here, and so we have all the targets tags that we apply to it. For me, it's going to be 3 different tags. 1 if we're applying, and 2 if we are removing it, of course. And we are getting a tag container with the dynamic tags. So now we have a dynamic tags container. So we can check that dynamic tag. Has it a tag of adding? So here's my adding tag. Are we adding this module or are we removing it? So that's what I'm checking here. And down here, I'm checking, are we removing it? And then if we're removing it, is it active? So we know that it is going to be added or removed. And we also know if it's active or not active when we're removing it. All right, so now we have collected all the information we need here. We're going to start evaluating our information, right? So the first thing we have here is a very, very important function. It's called attempt calculate captured attribute magnitude. So this is coming from the execution parameter, so that is of course the input that we have up here. So what is this actually doing? Well, we're grabbing our max energy definition here, right? And we're taking our evaluated parameters that we get up here. We can populate this with information that we can help us do a new calculation, but we don't really need any. And it's going to put that information or the value that comes out of this, it's going to put that in my max energy value, my power grid, and my data transfer. So we're grabbing the attributes. What is this? If we go back to our gameplay effect here and look at it, we get a value here, right? Right now at level 1, it's 7.5 in power grid, is 25 in max energy, and is 2.5 in data transfer. What it actually is doing is goes into your attribute and it takes the base value that is already there. And it do this calculation, so it's adding here, for example, 7.5 to that value. So if it is 0 and you add 7.5, the new value is 7.5. But if it's 10 and you add 7.5, now it's 17.5. So you get the whole calculated value into this file. So that means that the calculation has already been done when it comes here. This is purely the result of whatever happened in your gameplay effect. So when you go through this, these will populate these values with the value that is after you done your calculation. Now, what you can do after this is that you can change that calculation. You can put whatever you want. If you want to do a multiplication by saying that, okay, you do this additive in the gameplay effect, and then you want to do a multiplication to type 1.25, or you want to do whatever you want to do. You can do that in this file, and then you can transport that value and set it as the new value in the attribute set. So that's why this is so powerful. You get the first initial calculation from the gameplay effect. If you even do anything there, you might just say that you're going to use this gameplay effect and pass through the value as is, and then you do all the calculation in here. Me, I wanted to use a curve table, so for me it was easy to just use an additive and get the value between after the calculation. All right, and then we go down further down. So now we have the max energy value, we got the data transfer and power grid. So I want to check the power grid and data transfer, their values. So this is where this type of calculations are pretty powerful, because now I can say that I can create 2 bools here, right? A power grid above limit and a data transfer above limit. And I'm checking if the new power grid that comes in, if that is higher than the max power grid, well, then I can set the power grid above limit to true. And the same thing with data transfer. So now I have a check if we are above or not. If we're not above any of these. So I'm saying if it's not true. So now we know that both of these are false, and therefore we can apply the changes to my attributes. And here I can set the module to set active true. I can do whatever I want to happen to the module or the target. I can do those things in here. I can run functions, I can do calculations, I can do anything I want, right? And then here I'm just overriding the value on the, so I'm getting the attribute and I'm putting that into this output modifier, and I'm overriding the value in there. So I'm putting the entire new value of my power grid into this output modifier. And this is of course on top of our it comes from here, out execution output. That's where this comes from. So we are adding output, add output modifier. So we're doing a calculation, another calculation here actually, because you can actually do additive or multiplication or whatever you want here. So if I remove this and just there, you see you can do additive, division, max, multiplicative, overrides. I'm doing an override because I'm actually replacing the value that's already in there with the new value. So that's that, and then we're finishing off with a mark conditional gameplay effects to trigger. So we are triggering it, we're good to go, it is now added, and we let the gas system just take over and do whatever it needs to do. All right, so here's an interesting thing now, okay? This was adding, calculation is done, right? If we look at my file here, it's an instant. Here we go, the captured attributes. All this get updated. We can choose whichever captured attribute we want to use. This case is power grid. Here is max energy, and at the bottom is the data transfer. So this is being picked up, and we'll make sure that it's filled out properly and all that. Now I'm using the same gameplay effect if I'm adding or removing the gameplay effect, right? So the value is going to be a positive or negative. So it's always going to be a 25. So it's never going to be negative. It's always going to be positive. That's what I'm trying to say. So how do we calculate that? How do we remove it? Because if I remove it, I'm using the same gameplay effect, and technically it should just add it on top, add it on top, add it on top, right? So what I came up with, this was pretty late at night, so bear with me if I've done something that looks really, really weird, but I think it's pretty okay. So forget about this part here. We didn't have an adding attribute. We had a remove attribute tag, right? So we're checking, did we have a removing tag? Yes, we did. Was the tag, did it have the tag is active? For example, if we're dragging it off and it's not active, so it's going to not have this tag. It's going to have a null tag. Basically, it's going to have a remove tag when we drag it off if it's not active, but it's not going to have is active. So therefore, we're checking that. If it is active, we are setting the module to false when it comes to set active. And we're grabbing the same information. It's the same information with power grid, data transfer, and max energy value. Now we're grabbing the attribute set just like before. So the next thing we want to do when we come in here is that we're going to negate the values. And how do we do that? Because I have this basically value is, for example, I have 100 in max energy, and then I add it, so I have 125. And now I want to remove it. So this is going to be 150, right? That's 150 now. It's not 125, it's not 100, it's 150. So what we're doing here is we're grabbing the max energy level. So we have the current max energy level at the attribute set, because this value is before we change it. So all these numbers are before we change it. So this number is still 125. That is 150. This is 125 now. We get a current max energy value. So we're checking max energy to remove. How much do I need to remove from my current max energy value? value? Well, I'm taking the current max energy value, which is 125, and I deduct the max energy value that is 150, because 150 up here, and then 125 minus 150, so this is negative 25. All of a sudden we have a float value that is a negative 25, and that's what I need to remove from my current max energy value. So 125, I want to bring it down to 100 again, so I'm taking out 25. So I'm using, instead of override, I'm using additive down here. So I'm adding minus 25, which of course 125 plus minus 25 is 100. And then we're marking the execution as valid, and we're moving on. And that's how these are working. So the most important thing to take out from this video, this is going to give you a total value of the calculation, the total value of that calculation. And this is just setting that value for you with additional calculations if you want it. Here we have an additional calculation because we're grabbing that current max energy value and subtracting the max energy value to get the minus 25 in this case. And the same thing is with these other things. So this is pretty powerful, and you can do whatever you want to do in here. If you want to grab information from left or right, then just grab it and put it in here. And the real strong thing here, because you can get multiple values from multiple attributes and combine them and do the calculation that you really need, that you really want in Unreal Engine to use in your gas project. So if you never use this, start playing around with it and start understanding how these things work. The more you understand about it, the more you will love it. If you have any questions, populate them below, subscribe, and I'll see you next time on Swap Up Gaming, and come into my live stream. It could always be fun to talk and chat and learn things together. So I'll see you then. Take care. Bye bye.